Hello everyone and welcome to this video on Kubernetes, also known as K8s. In this tutorial, we'll be covering everything you need to know about Kubernetes, from its definition, to its architecture, to its practical applications. So, whether you're a developer, a sysadmin, or just someone interested in learning more about container orchestration, this guide is for you. But first, let's start with the basics. What is Kubernetes? Kubernetes is an open-source container orchestration system that automates the deployment, scaling, and management of containerized applications. It was originally developed by Google and is now maintained by the Cloud Native Computing Foundation, CNCF. With Kubernetes, you can deploy and manage containerized applications across multiple hosts and clusters, without worrying about the underlying infrastructure. Now, let's dive into the architecture of Kubernetes. Kubernetes architecture. At its core, Kubernetes has a master node and multiple worker nodes. The master node is responsible for managing the entire cluster, while the worker nodes run the containerized applications. The master node has several components, including the API server, the etcd database, the scheduler, and the controller manager. The worker nodes also have several components, including the kubelet, the container runtime, and the kube proxy. The API server is the central control point for Kubernetes, and it receives all the commands and requests from users and other components. The etcd database is a distributed key value store that stores the state of the entire cluster, including information about the running containers, nodes, and services. The scheduler is responsible for deciding which worker node should run which container, based on factors like resource availability and workload balance. The controller manager is responsible for maintaining the desired state of the cluster, by continuously monitoring and reconciling any discrepancies. The kubelet is an agent that runs on each worker node, and it communicates with the API server to receive instructions on which containers to run and how to manage them. The container runtime is responsible for starting and stopping containers, and it can be either Docker or another runtime like RKT or CRI-O. The kube proxy is responsible for handling network traffic within the cluster, by setting up network routes and load balancing rules. Now that we've covered the architecture of Kubernetes, let's look at some practical use cases. Kubernetes use cases. Kubernetes is used by many organizations to deploy and manage their containerized applications, especially in cloud environments. With Kubernetes, you can easily scale your applications up or down, depending on demand, without manual intervention. You can also roll out updates and new features without downtime, using techniques like rolling updates and canary deployments. Kubernetes also provides built-in features for monitoring and logging, which can help you diagnose and troubleshoot issues in your applications. Conclusion. And that's it. We've covered the basics of Kubernetes, including its definition, architecture, and use cases. If you're interested in learning more, there are plenty of resources available online, including official documentation, community forums, and tutorials. Thanks for watching, and happy learning!